Hello and welcome to Meet the Experts. I'm Tim Barnes, Science Education Specialist here at NCAR. And today we are going to be networking at the speed of light. If you've ever wondered how the inside of the internet works, Carlos Rojas-Torres, a network engineer at NCAR, is going to be here to just turn the whole thing around so you can see what's behind the curtain and find out about WANs and LANs and gigapops and lasers and optics. But before that, let's make sure that you have what you need. If closed captioning is what you need, live captioning is enabled. So you should be able to turn that on right there at the bottom of your screen. And if you have questions along the way, please feel free to enter those into the chat. We'll be taking questions along the way and also at the end. So with no further ado, everyone would like to introduce Carlos Rojas-Torres. Hi, welcome to Meet the Experts.
Hi, Tim. Thank you. Hello, everyone. So my name is Carlos Rojas-Torres. I'm a network engineer at the University Corporation for Atmospheric Research, the National Center for Atmospheric Research. And I mostly work on the Front Range GigaPoP, which is a regional nonprofit network managed by UCAR, NCAR. A quick background about myself. I went to college in Chihuahua, Mexico. I pursued a bachelor's in business administration with a focus on marketing. Later on, I went back to the Front Range Community College here in Colorado, got a certification in geographic information systems. And currently, I'm pursuing a master's degree in computer information systems at CSU in Fort Collins. So like I mentioned, most of my time as a network engineer working for NCAR, I actually work on the FRGP, which is the Front Range GigaPoP, the regional nonprofit network that we manage. This network was created in 1999. It's a partnership between more than 30 members. The members range from government, nonprofit, research and education. Some of the, you can see the logos there. We have CSU, Colorado School of Mines, State of Colorado, State of Wyoming, Air Force Academy, University of Colorado, CSU Pueblo, UCAR, NCAR, NEON, NOAA, you name it. A lot of these really cool institutions are members of our network. And they basically got together to have really high quality internet and networking services at a better price, so they can share this with their students or the government members, or on and on. So let's talk a little bit about what is a network. So a network, the most basic network, is a connection between two computers. So when you plug one computer to another one with just a simple cable, that's already a network. Once that you bring a third computer, now you're going to need a little gadget called a switch. And the switch, basically all it's going to do is going to manage the communication between the 3 or 4 or 5 or as many computers or gadgets that you have in your home or in your school or any institution. So a small network like this that is confined to a building is called a local area network. And these local area networks are connected to a bigger network, which are the wide area networks. Those networks, they work by connecting one local area network to another local area network. So around Colorado, the United States, and the world, there is like thousands or millions of these local area networks connected through these wide area networks. So just like the little networks, the local area networks, to manage the flow of information between them, we have these machines called routers. The routers, they basically work like a street light. They give the green and the red to the information as it's flowing by, just so there is no collisions in between the information. It also knows where to send the packages. So when you type something in Google, it's sending a package with an address that says, hey, I want to talk to this side of the world, and I want to gather this information. It goes with a little address in there. So the routers know where to send that and then to send it back to you with your response of the data that you are looking for. So the networks usually work between, it can work on copper cable, it can work on fiber optic, it can go wirelessly, or it can work like with the satellites. Our network runs on fiber optic. And what is fiber optic? Well, this is a little cable of fiber optic. Most of what you see is just the yellow jacket and the two ends, right? But inside of those, there is a little hair of glass that runs from one side to the other one. And light can run through it, moving data through it. So let me show you a little bit of how this works. So right here I have a laser, which is one of the tools that we use to troubleshoot our network. There you go. So typically the light is gonna travel straight, right? So if you cover the light, it won't go through. However, with a fiber optic patch or fiber optic in general, you can make the light actually go around places, go in circles, and then you can see the other end is going to have this light shining through again. You see that? So how cool is that? The light can actually be bent and travel around different geographical areas. So we can see a little video that is going to explain this concept with water. So what you're seeing there is somebody's he made a hole, a scientist made a hole on that bottle. Then he's gonna fill it up with water. Now we have a flow of water falling down from the bottle, right? Now they're pointing a laser to that flow of water. And do you see how the laser, instead of going straight, is following the water down? Well, this concept was presented in 1854 by John Tyndall. He demonstrated that the light could be conducted through a curved stream of water, proving that the light signal could be bent. So what is happening is that the water have the property of being able to reflect light not only on the surface, but also internally. So this is where the basis of the water later, because of this is the base of what later on was known as fiber optic. After John Tyndall demonstrated this experiment back in 1854, it took more than 100 years for the science and the technology to get to what now is fiber optic. So why fiber optic? Why do we use fiber optic? Well, because it's really fast. Just imagine, in theory, this is moving at the speed of light, and it can carry a lot of information. So let me show you something else. When we deploy our fiber optic around around the networks, we need to be really careful on how we deploy it. Sometimes this fiber optic runs under the water, under the sea, through the mountains. Sometimes when you see construction workers on the side of the road, what they are doing is they are actually installing fiber optic. So let me show you. I'm going to send light through this fiber optic, right? And I cut one of the ends. So you can see that little hair of light, how it's happening. That's what happens sometimes when you're at home and your internet goes down and all of a sudden you cannot watch Netflix or YouTube. Well, it's because somebody was on the street digging a hole and they cut one of the fiber optics that supplies this information on the internet to the neighborhoods. So another tool that we use to troubleshoot our networks when something is happening is something like this. This is an optical light source. So what I'm going to do is I'm going to turn it on. This is one end of my fiber optic. I'm going to connect it to it. And now it's sending a signal through the fiber optic. Then on the other camera, you're going to start seeing the other end of this. So this right here, it's a pretty cool tester. What it does is it's going to read the power that I'm sending through this fiber optic. So let's see, we're receiving 0.45, let's say, right? So right now I'm sending 0.45 dBs from here, through my fiber optic all the way to my reader here. So we're at 0.30. But look what happens. If I take my fiber optic, then I roll it, and I start pinching it, look what's going to happen to the power over there. We're losing a lot of power. So what is happening is the light cannot flow anymore. So just imagine how careful in all the infrastructure that we have to put on the ground for the fiber optic to be safe from one city to another one. Because if a kink like this can stop the communication from city to city, just imagine how delicate and how important these systems are. So once that it's really resilient though. So once that you let go, the power should go back to the levels that they were before. Although there is a point where if you bend it too much, you can actually break the fiber, and then you're gonna have to come and somebody's gonna have to dig it out and fusion splice it is called, when they're gonna cut it and then fusion splice the two pieces of glass so our network goes back up. Another thing that I'm gonna show you here really cool is I'm gonna change this. This is also a microscope. So I'm gonna put my fiber end here to the microscope part of it. If I can find it. There you go. So look at that. That's the end of our fiber, and look how dirty it is. So another thing that we have to do when we are deploying these fibers is we need to be extremely careful when we touch them, because any of that, and that can be anything from grease or something. Look, I can change it a little bit. If I just put my palm, I'm gonna make it even dirtier. But look how easy it changes, and now it can be blocked by some of those little dots. So we need to be really careful and really clean when we are doing this. We have all kinds of different tools. We have cleaners, we have the microscopes, we have the testers to make sure that the network is always up and running, and everybody have, a good internet signal to their schools and to their homes. So let's see.
Wow.
What else? Tim?
Carlos. Yeah, that's amazing. The speed of light and keeping the glass clean, and you can send it distances. What would happen? Actually, we have a poll question. Let's see what our viewers think. What would happen if we could wrap a fiber optic cable around the Earth and shoot light through it? How many times would the light traveling through that cable go around the Earth in 1 second? And you should see a poll window pop up for you. So go ahead and give us your input. What do you think? Because it's moving at the speed of light and it can go over mountains and underwater. What would happen if we could wrap a fiber optic cable around the Earth and shoot light through it? How many times would the light travel around the Earth in 1 second?
Awesome. That's a really cool question. So while they are answering that question, I can tell you that as far as the light goes, it will go through. Now, the data that is sent through light, the further point that they can go without being regenerated, meaning that we need to stop at a certain point and then kind of recapture all the data and send it again, is 400 kilometers, about 250 miles. So every 250 miles of this data going through the fiber optic, we need to stop, regenerate, and send it again. So across the cities and across the nation, we have a lot of what they are called nodes, where we have some special equipment where the light will arrive and then we'll send it back out on their way.
Wow, there's a lot of information there. And you did break up a little bit in your explanation. So maybe you could reiterate a little bit of those bits and pieces in the light of our poll responses. And it looks like some of our viewers think 5 times, some think 8 times, and some think 20 times. What would be the proper answer there?
Cool. So those are really good guesses. If we were able to send the light nonstop on a straight line for the distance, it will be about 8 times. However, we are traveling inside the fiber optic. What the light is doing is bouncing all over the place inside that little hair of glass. So it's going to take about 30% longer, meaning 5 times only instead of the 8 times that it would be if it was a free beam of light.
Okay. And So we do have a question in regards. Thank you so much for that answer. And we do have a question of you mentioned that you could splice glass. So one of our viewers wants to know, how do you splice glass in a broken fiber optic cable without refraction?
Right. So there is a little machine called a fusion splicer. And what you do on the field, I don't know if you're going to be able to see this little, I mean, it doesn't make justice, but it's so tiny and you have to be really careful. But it's just a little piece of glass, right? Like a hair. And it's, so basically what you do on the field, you have different tools, something like this. And it's going to take all of the coating because on top of that, you can see it already, but it's actually thinner than what you saw. And you take the coating off, then you have the bare glass there. And how it works is you put this piece of glass on one side, inside of the machine, and it's gonna hold it. Then another piece of glass on the other side, and it's gonna hold it. And then you close this machine, and by itself, it's gonna line it up perfectly, and it's gonna heat it up on a way that it's gonna fuse the glass right in the middle. Before you can take it off, there is a little tube that we're going to put on top of it, and it's going to melt it on top of the glass so the glass cannot be broken again. That's how fusion splicing works. But just think about this. A lot of times, this happens in the middle of the nowhere. They have to dig a hole. They have to be really careful once they get to the fiber. Somebody has to come in, open the fiber, get both of the sides nice and clean before they can fusion splice it. So it's not easy. There is a lot of people that does this for a living. All they do is fusion splicing around.
Wow, that's incredible. So how much did, oh, we have some pictures of what you were just describing. Would you like to talk a little bit about what we're
Right.
seeing?
Sure. So what we're seeing here is like each one of those colors that you see there is called a buffer. So that cable is actually a big cable. Those you can see on the street when they are putting or installing those cables underground, and they are pretty big, pretty thick. But inside of that cable, there is all kinds of components that all they are doing is protecting the fiberglass. So as you see there, we have 2, 4, 6 different buffers. So the buffer is basically like that outer jacket that you see there. Inside the outer jacket, you have the string member, which is just another material that is going to keep everything nice and flexible. Then you have the coating. The coating is just like a white little plastic that is in there. What you can see here is not even the glass; it's just that coating. Then you're gonna get to the cladding, which is already some kind of like component, almost like glass, but it's all broken down. And then finally you get to the core. Now, each one of those buffers can have 12, 24, 36 fibers on each one of them. So across the highways and stuff, we have like hundreds of fibers just running from one side to the other one, and different companies own different pieces of that fiber. And that's kind of how it works.
That is amazing. So with all of this technology, how much data can you actually move through a fiber cable?
Well, our network, and I'm gonna show you a quick picture of our network just so you understand like where we run from. There you go. So the top here on the north, this is Wyoming. That's Cheyenne, where we have our supercomputer, and this is Laramie, where we have University of Wyoming that we actually serve in our network. And then all the way south, we go all the way to Pueblo, and some of our members actually connect all the way here from the Navajo Nation near Albuquerque in New Mexico. But like, let me zoom out. You can see the size of our network compared to the United States. Now, our network, just like our network, there is other networks on other states next to ours, and they all connect together. They go all the way to Seattle, San Francisco, Los Angeles. Then they go across the Pacific Ocean all the way to Hawaii, and then they ended up in Japan. And across the world, there is a lot of different networks connecting to each other, and they all work together on to bring us basically the internet. That's how the internet works. It's just networks connected to other networks. So now talking about speed, I'm gonna stop the map for now. And then I'll show you about the speed. So basically what we do is we divide the light that goes through the fiber into different waves or colors. So with the components that we have in our network, we can use up to 40 channels or 40 colors, right? Each of those channels has the potential to run up to 400 gigabytes. So we have 40 channels that can run up to 40 gigabytes. That's a lot of volume that we can move on the best case scenario, and it's tough to imagine like exactly what is that like. So basically, if we had this at 100% capacity, running 400 gigabits per channel, we will be able to download all of the Netflix library in less than 10 seconds. Of course, that we will need a supercomputer and a lot of components to download that. That's how fast we could run everything through our network.
That's amazing. That is absolutely amazing. Um, and there was another question about the way the internet moves under oceans. How do you connect networks across oceans?
So basically, what happens on the ocean is the fiber optic is actually just laid on the bottom of the ocean. It's just laying there on a huge cable. These are a lot more protected because they have to be watertight. But there are crews that are just running these huge cables across the ocean from one side to the other, and it's just fiber optic running down there.
That's incredible. Well, what skills would you say to do your job? What kind of skills does a person need in order to do this type of work?
Well, I think you need to be curious because technology is always changing. So you always have to be like curious about what is coming on. If you don't keep like learning new technologies, you're gonna stay behind, and then I would not be able to do my job. You need to have attention to detail. As I show you, it's really easy to break one of those fibers or to get it dirty, and the whole network will stop working or will start throwing some errors, and we cannot have that. So you need to be attention. You need to pay a lot of attention to the details. Then we work with a lot of different people. We work with vendors. We work with other networks. In our team, we have about 10 engineers that we all work together to make this happen. So communication skills are key. We need to be able to communicate with each other to make sure that we are all in the same page. Then you have to be self-motivated and confident because when we go and deploy something or we are trying to fix the network, it's not like we can just walk away when we are tired and go take a nap or go take lunch. Like we need to be there until our network is back up. We have a lot of people depending on us to have this up and running. And
Well,
then confident. You need to be confident when you are on the middle of the field. Sometimes you are by yourself and you are putting some command lines or something, and you cannot hesitate on doing your job. Um, Sometimes it doesn't work, but you need to have the confidence to just go for it. And if it doesn't work, it doesn't work. But most of the time, hopefully, we'll get it right.
well, I'm super impressed, Carlos. And we have a question in regards to that effort, and this comes into us from Wyoming, from Summer, who's works for NCAR, and she says that UCAR NCAR studies space weather such as solar flares, and when a solar flare is forecast to happen, what can internet providers do to prevent interference or network managers or something like that with the FRGP?
Well, one of the things that most networks have is redundancy, meaning each piece of equipment that is working, it has like a backup machine. So if something all of a sudden happens that will bring down our main machine, the second one will catch to it. The other thing is we work in rings. So any connection has another connection that goes on the other side, and when one side of the connection goes down, the other one automatically will light up and start carrying the network. Now, sometimes when like a solar flare is going to happen, and if there is like a big danger of our equipment being damaged, sometimes the network has to be shut down for that kind of situations.
Excellent. So, could you just walk us through the day what happens in the day of a life of your for you, a network engineer?
Right. So, like I say, communication is key on what I do. And so I do have every day, I have a couple meetings with my team. We do a lot of planning depending on like if we need to grow or network or if there is something to be fixed. We do some planning. Then I do a couple days a week, I go out into the field. I leave my office, go into the field and do site visits. There is a lot of documentation or fixing things or just monitoring that everything is in a good state. I get to visit universities, laboratories, schools. So I do a little bit of traveling on the region to make sure that everything is right. I do a lot of documentation, like the map that I showed you before that is interactive and is online. We created that map and we manage it and we maintain it. Then a lot of the documentation we create, actually all of the documentation we created ourselves, and some things tell you different things. Like on the we do geographical documentation, and then we do diagrams just to know like what's connected to what. So that's kind of like how my day goes usually.
Usually. There you
Yeah.
are. Is that you working on the systems?
Right, that's me working on the field. Yeah, sometimes we have to go on the field. Sometimes you have to go at midnight or 1 in the morning, depending on what's going on. But it's always fun.
Wow. Again, everyone, this is your opportunity to add some more questions to the chat if you have them for our guest Carlos Rojas-Torres. Um, and while we're waiting to see if there's any other questions, what's your favorite part of your job, Carlos?
I really like the fact that I do a lot of different things. Like I said, sometimes I need to travel. Sometimes I need to um, go to different places. I go to like Wyoming and stuff like that. I really like the design aspect of it. I like bringing new members into our network. That's always exciting. So I like the fact that I do a lot of different things. It's never boring.
Wow. And we're still looking. Oh, what are the entry level jobs in this area? That's a question that came in. What are the entry level jobs?
Okay, so in my case, I actually started as a network technician. A network technician can specialize in deploying the fiber optics. So kind of like a nurse to a doctor. You make sure that all the equipment, you make sure that everything is laid out so the engineer can take care of it. Little by little, I made my way up to the engineering part of it. I went back to school. That's when I went back for my geographic information system certificate. And then I also took a few certificates with some of the vendors that we use, like a specific equipment that we have in the field. So an entry level, I would say, is a network technician or network engineer one, as you start performing some of the basics.
Okay, and we're coming up on time right about now. We may have another question come in. If we don't, Carlos, do you have any, as we're closing up here, do you have any, let's see, so actually we do have a question that came in. What was your career path to get where you are? Can you walk us through how you got to where you are?
Yeah. So actually, like I mentioned in the beginning, I went to college to be a business administrator, and I really like publicity and marketing, so I took a major. I majored in marketing. I was nowhere near technology, but in one point, I started working for the National Center for Atmospheric Research as a network technician. Um, Based on the fact that I learned how to do fiber optic. Little by little, I started um, getting some certifications under my belt because I really wanted to become an engineer once that I saw that. And before that, I was never exposed to what networking was. And once that I got some certifications under my belt, they gave me the opportunity, and then I became an engineer one. And over the years, I became an engineer two, and hopefully soon I'll be an engineer three, and on and on.
Excellent. So Do you have any advice for people who are interested in this area?
Yes, absolutely. You, like I said, you need to be curious. So everything that you can learn about technology, just always pay attention to it and see what's coming, and just keep your mind open to new technologies and new things. Like if you, when somebody sets on their old ways and just trying to stay with the current technology, that's not really good when you are trying to get into a field that is always moving.
Well, that is some really sage advice to stay fresh and on your toes and learn everything you can. And it's an incredibly interesting occupation you have, and you're obviously very good at what you do. So, everyone, that we have some thanks coming in, some thank yous coming in already on the chat. So, we really appreciate your coming to talk with us today, and thank you all for tuning in for networking at the speed of light here on Meet the Experts. I'm Tim Barnes, Science Education Specialist here at NCAR, and we would like to let you know that that was the final Meet the Experts for the spring and summer here. We're going to take a little bit of a break, but you can check our website later for this summer for the fall schedule at scied.ucar.edu. And we will be sending the survey out to you again. And in that survey, if you would let us know what topics and careers you want to explore right in that survey, and then tune back in to see what's on our schedule. And you can follow us on social media at at UCAR Syed on social media for more events and programs this summer. Thanks again. We'll see you next time.